Now, yesterday we did a brief little introduction. We started 2.3, solving inequalities by multiplying or dividing. First thing we started to look at was 7x greater than negative 72. Whenever we have the problems, when it was an equation, how do I get rid of the variable being multiply? Divide. So I draw the wall. Some of you draw the wall, some of you don't. I need to divide by 7, divide by 7. X is greater than, what's negative 72 divided by, or sorry, negative 42 divided by 7? Negative 6. X is greater than negative 6. So to check my answer, or to graph my answer, I'll just use my ghetto graph. I'm going to use negative 6. Is it an open or closed dot? Open. Why is this one an open dot? Because it's not equal to. Does it graph to the left or the right? Why does it graph to the right? Because it's greater than. It's not because that's the way the arrow points. I know that's the way that some people think. That's the way the arrow points, that's the way the graph goes. Yes, with the variable on the left, that is the way it points. But if the variable's not on the left, it doesn't point that way. Give me a number greater than negative 6. Give me the best number greater than negative 6. 0. What's 0 times anything? 0. Is 0 greater than negative 42? Yes. So I know I'm correct. This one here. I have 2.4 is less than or equal to m divided by 3. Too many people see these problems and say, I can't do them. There's a decimal and there's a fraction. There's not technically a fraction. On the right-hand side, that says divide. It doesn't say a fraction. On the right-hand side with that division, how do I get rid of division? Multiply. So how do I get rid of a multiply by 3? Or sorry, how do I get rid of a divide by 3? Sorry. Multiply by 3. Multiply by 3. By multiplying by 3 gets rid of the dividing by 3. Now, without a calculator, I'll take the whole numbers. The 3 times 2 is 6. Now the decimals, I'm throwing out the decimal. What's the 3 times 4? 12. How many decimal points did I have? Throw it back in, so it's 1.2. What's $12 plus $1.2? Or sorry, $6 plus, I'm messing up today. $7.20. 7.2. Now, I can flip it to make it a little bit easier to graph. Now, when I flip it, everything flips. M greater than or equal to 7.2. I don't have to do this, but it does help me to graph. Bless you. To graph. 7.2. This one is open or closed? Closed. And this graphs to the right because it is greater than. M is greater than or equal to 7.2. It's a lot easier when I have the variable greater than or less than. It's a lot harder for you to think when a number is less than. What do I need to do in order to solve this problem? Why divide by 5? What's being multiplied by 5? The q, the variable. So divide by 5, divide by 5, divide by 5. Negative 10 greater than or equal to Q. Now I can graph it as is. That's fine. Some of you are starting to flip it. I'm seeing that. Q less than or equal to negative 10. So to graph it, negative 10, a solid dot, and it goes to the left. All right, we already just said, and I forgot to hit the record button. The only time that we change the symbol is we multiply or divide by a negative. But you do not just change the direction of the inequality just because you see a negative. We've already dealt with a couple problems already that had a negative in there, but we didn't change anything. The only time that you change is when you multiply or divide by a negative. So I have a problem here. Do I have to multiply or divide? Divide by negative 12. Divide by negative 12. X. Now I'm gonna act like I don't know the rule. Greater than. Positive divided by negative is negative. 84 divided by 12. It's not 6, it's 7. So give me a number greater than negative 7. No, give me a number greater. 5's greater than negative 7. What's negative 12 times 5? Negative 60. Is negative 60 greater than 84? No, it's false. Because what's happening is, when you're dividing by negative, you're changing the sign of everything. You're changing the sign, you're changing the sign, you're also changing the sign here. This becomes a less than. Whenever you multiply or divide by a negative, you change the symbol too. So give me a number less than negative 7. Negative 10. I was going to say give me a nice number less than negative 7, and that's negative 10. What's negative times negative 10? 120. Is 120 greater than 84? Yes. So we're good. Graphing it, I have negative 7. It's an open dot, and it goes to the left. Anything over here will work. Try this one. I'm being divided by negative 3, so I have to multiply by negative 3. Negative times a negative is a positive. 3 times 8 is 24, less than or equal to x. X is greater than 24. So I have 24 closed to the right. See, now here's the word problems. Oh, sorry. We switched the sign. The reason why I switched the sign, see, I just automatically do it. It's a habit. You switch the sign because whenever you multiply or divide by negative, you flip the symbol. What's that? I always switch it around whenever I multiply or divide by negative. Sorry, I made the mistake. I made the mistake. Thank you. 24 greater than or equal to x. X is less than or equal to 24. See? This is why you also have to challenge me. I make mistakes. I'm not perfect. Don't always take my word as being correct. If you think I did something wrong, speak up. Even if you're only one person that think I am wrong. You never know. You could be that one person that is correct. Don't feel bad. Don't feel like you're going to be that one student that says, I don't want to look bad in front of my classmates. Speak up. Always speak up. You see these word problems and say, I can't do these. But the thing is, these word problems, this is your real life things of where you see these problems. You do these all the time when you go to the store. You have a certain amount of money in your pocket. You go to the store, you know you want to buy a certain amount of stuff. You always want to buy as much as you can, right? You want to go and you want to buy as much fruities as you can. So you got to figure out you have so much money. You know you have to spend, or fruities cost, I'm just throwing out this. The tubes of paint are $4.30 after tax. What are the possible numbers that I could buy? So the first thing I do is set it up. What do I know I have total? $20 is the total. That is my maximum. Since that is my maximum, what does that tell me? It has to be less than or equal to. I can't go above that, but it can equal that. What do I know about my tubes of paint? They're $4.30 a piece. So 430x, I heard someone say. Now we'll just say x is my tube of paint. What do I do to solve? I divide by 430. Now, for these problems, I don't expect you to know this in your head. These are the problems I'd say use a calculator for. These are the problems I say do in your head. X is less than or equal to 20 divided by 4.3. Why didn't I put the 0 there? It doesn't matter. I don't need it. If I put it there, that's fine. If I don't, I don't. Enter. I'm going to put 2 decimal places. 4.65. So, realistically, can I buy 4.65 jars or tubes of paint? No. Really? No. Go to the store and buy me 4.65. Go to the store. Go to the store and buy me 4.65 bags of chips. Can you do that? No. Can you buy point something of anything? So what does this mean then? Round it down. So it's x has to be less than or equal to 4. Can I buy 5 bags or 5 tubes of paint? Why? See, now I'm getting you to think. I don't have enough money to buy 5 tubes of paint. I only have enough money for 4. These are those types of questions you see on the tests. Foresights, PSSAs, you're going to see them in the Keystones, those things. What's the maximum number of tubes of paint that such and such can buy? It's 4 tubes. You can't buy 4.65, sorry. You can't buy a part of something. You can't go in the store and say, yeah, I want 4.65 of something. You buy 4 of it. We don't round up.